All right, let's get started. I was just looking at time.is, excuse me, and it's time to get going. Good afternoon, everybody. Hopefully you had a good time since last time we met. I've been pretty busy. And so it's time to start another wonderful afternoon of organic chemistry, Chem 170, with your host, me, Dr. White. Now, I have a special surprise for you. For those who are interested, stick around after I say goodbye, and I'll show you a really interesting picture of me with a couple of my sister's sheepdogs. For those who are into pets, I think you'd love it. And I'll show that after I say goodbye because I'm going to cut it out of the video. Speaking about videos, I got a little behind and hopefully I'll stay on top of things, but I'm up to date on all our videos. So for those of you like looking at the video, it's on the YouTube channel. All right, let's get back to work. Now, oh, a couple of quick announcements from the management me. One, make sure you're handing in your labs. They're easy 11 point. Well, I only have 10 fingers. Imagine I grew an extra finger. Anyways, 6 plus 5, 11. They're an easy, it's not too good humor Monday. But anyways, hand in your labs. They're at 11 points and they're not hard to get. All right, next thing. On Wednesday, I will go through the alcohol problem set. And finally, I'm getting into the swing of things here. And probably on Tuesdays, I'll be posting your grades from the lab you handed in last week. And that way I'll keep up to date and not fall behind because that's not good for me or you. All right, with that, let's get back to work. Now, last week, and can everybody see the reaction with an alcohol on your thank you? Thumbs up, people. I was showing you the reaction of if you take an alcohol and react it with ethylene oxide. Actually, this will work with any epoxide, but for this class, I'm going to stick to ethylene oxide. And in the United States, it's probably one of the widest used epoxides, period, in chemistry for making products. So we have ethylene oxide alcohol. We did some of these, and let's do a practice uh, problem. I'll do one, then let you have fun. Uh-oh, why is my hanging there? Oh, I know why. Wondering why isn't it working? The eraser was still on. Duh. All right. And normally on test number 2, I'll say organic product or products for. And let's try one. And I'll do this one, then I'll let you have fun too. All right, so give the organic product or products for the following. And if we look here, look for what's different. What's not a carbon, what's not a hydrogen. Ooh, an oxygen with a hydrox group on carbons, that's an alcohol. What do we have here? Ooh, ethylene oxide. And as I mentioned last week, Dr. White did a lot of work with ethylene oxide with alcohols and other molecules in industry. And what you get is this ether alcohol. Remember, this is an ether. Remember, ethers have this functionality, and this is an alcohol. and you have two functional groups in a molecule. And later in the semester, we'll talk more about this. Right now, I'm keeping most of the stuff to one functional group. So what's my R group? Cyclohexane. Do you break carbon-carbon single bonds? No. Sorry about the phone. Two more rings. Hold on, let me look. And it's not the Secretary of Defense or anybody else from Washington. So one more ring. The reason I'm not turning off my phone is sometimes I do get important phone calls, but most of the time I don't. Anyways, so I have my R group and I have oxygen and CH2, CH2OH. And that's how you do it. And let me have you try one. Ooh.
Can you scroll back up to the first problem?
The answer is yes. As you found out,
Thank you.
Dr. White has one of the fastest mouse wheel fingers this side or the other side of the Mississippi River, or any other river you want to think of in the United States. Or I could say this side of the Atlantic Ocean, and the other side too.
Okay, I got it. Thank you.
You're welcome. And remember, all questions are good questions. And why don't you try this one? What would be the organic product or products for the following? For those who came in late, don't forget to hand in your labs. And when you're done, give me a thumbs up. If you don't have your screen video on, give me the emoji thumbs up, or other ones too. Ooh, I just thought, I think I might have mentioned it, but all right, someone gave me a text message thumb up. So I think you're all done. Let's do it. Look for what functional group. And that's really what I mean by saying look for what's different. And a functional group is going to be something besides carbon, hydrogen, or carbon-carbon single bond. And you look for the easiest way to find it is what's not carbon, what's not hydrogen, what's not a carbon-carbon single bond. Ooh, oxygen with a hydroxy group on carbon, alcohol. What do we have here? Ethylene oxide. And what do you get? An ether alcohol. By the way, the bond, the carbon with the hydroxyl group is the carbon this oxygen is bonded to. So what's my R group? A T-butyl group. Do you break carbon-carbon single bonds? No. And then I'll have my oxygen, CH2, CH2OH. Put in my hydrogens because I know there are 4 bonds to carbon, and I'm done. At this point, if we were face-to-face in the lecture room and a classroom at ECC, I'd say, I'm going to write something on the board. Don't copy it down. You don't have to, but keep an eye on what I'm doing. And I'll say the same thing now, too. All right, let's look at that reaction we just did, but let's try something simple. Methanol plus ethylene oxide. And you're going to say, oh, that's an alcohol, and you'd be right. And that's ethylene oxide, which is correct. And the product you get is this ether alcohol. And what's our methyl? So what I would get would be this molecule. And now I would say, what if I take this molecule we just made and react it with more ethylene oxide? And now this whole thing is my R group, because at the end here, I have an alcohol, and alcohols react with ethylene oxide. So what would I get? Here's my R group from the alcohol. And then I'd add on to it this. So I will. And if we look at this molecule, what do we have here? Well, we have an ether here, and an alcohol here. So if I take this and react it with more ethylene oxide, this is the R group of my alcohol. And I'll write it down here because I think I'm running out of room. And this is my R group. And now I'll add another of these. O, CH2, CH2, OH. Someone have a question? Or just
You lost me.
Oh no, I lost you. Let me see if I can find you.
Yeah. Keep
All right.
going. I'll try to catch up.
No, that's a good question. If I lost you, I might have lost other people. So quick, call the mounted police or someone, get the dogs out. Well, all right, let's go through this again. Right here, I start with an alcohol and ethylene oxide, and I make this ether alcohol. Everybody with me? And I'll say, give me a thumbs up if you're with me so far. All right, now, the molecule I just made, what is the functional group I have here? Carbon with a hydroxyl group. It's an alcohol. And if I react an alcohol with ethylene oxide, I drop the H and put on CH2, CH2OH. So this is right here, my R groups, CH3, O, CH2, CH2. I drop the H from the OH and put on another CH2OH. Are you with me so far? Now, this molecule right
Yeah.
here,
Where do we get the second?
you add it.
Oh, okay. Oh, yeah. Okay.
Okay, that's a good question. Or,
Okay.
and I'll explain a better way in a little while. Let's put it this way. Ooh, this is something I've never used. Say you had a piggy bank and you put in a penny, and then you put in another penny. How many pennies do you have in a piggy bank? 2 now. Well, here I started out, I added some ethylene oxide. Now I'll add more. And I'll make this compound. If you look at this compound, at the very end, I have ethylene an alcohol, and alcohols react with ethylene oxide, drop the H, add CH2, CH2OH, which is what we've done up here. Drop the H and add CH2, CH2OH. Well, that's what I have here. Now, one of the things I haven't done this semester, but I'm going to do it now, is if you notice right here, what I've just outlined. Oh, I'm going to go Technicolor on you. Notice I have a repeating group. OCH2, CH2. How many times is it repeating? 1, 2, 3. Therefore, I can use parentheses to rewrite this molecule CH3, O, CH2, CH2. That's to put a bracket and subscript 3. And then notice the hydroxyl group is on the outside. And I can write this that way. They're the same molecule. Now, let's take a look at why I did this. If we look at what we started with, we started with this alcohol. We added 1 mole or molecule of ethylene oxide. Then we added a second one, and then we added a third one. Ooh, that corresponds to the number 3 there. So another way I could write this reaction is the following. Everybody with me so far? If I have an alcohol and react it with N moles of ethylene oxide or molecules, remember mole is the counting unit of chemists, what do you get? This polyether alcohol. And I showed this is true by this example where I added 3 of these, 1, 2, 3, and N here was 3. So the reaction, this is a good general reaction. So let's try one more. And if we jump back to you'll see I have the following. I have these orders reversed, and it really doesn't. Here's when you react with 2 or more moles of an alcohol. Ooh, that reminds me. Did I tell you coming up in December is my birthday, so you got a long time to wait. You know what my all-time favorite birthday gift would be? A mole of pennies. Do you remember from general chemistry, a mole is 6.02 times 10 to the 23rd? Just give me a mole of pennies. That'd be 100 million piles, and each pile is $1 billion. I don't think there's that much money on our planet right now. But all I want is a mole of pennies. All right, so if we go back to our reaction, now that I got that out of my system, what do we have here? What's different? A hydroxyl group on a carbon, alcohol. Ooh, this is unusual. Number 5, which I'll use N. N is always a whole number, and that's moles of ethylene oxide. And what do you get? O, CH2, CH2, close bracket, and OH. Listen carefully. Common mistake students make. They try and put the OH inside the bracket, which is wrong. Nothing like that exists. It's outside the bracket. So what's my R group? Ethyl. Then I'm going to have my bracket, this right here, OCH2, CH2, close bracket. What's N? The coefficient, the number in front of ethylene oxide, 5, and hydroxyl group. And that's how you make it. Now, it turns out these types of poly meaning many, ether alcohols are used in many things, including cosmetics and different personal care items and a whole lot of other things. So I better let you try one of these. And why don't you try this one? What would be the organic product or products for the following? When you're done, give me a thumbs up. Let's see, one thumb up. Actually, I was thinking, what if I had a student without thumbs? That would be sad, but I knew of someone who worked on a farm, got this part of his index finger disappeared in a farm accident, so I guess that could happen. Is everybody, if anybody's offended by my thumbs up thing, let me know in private and I'll come up with a new one. That could be dangerous. All right, I think everybody's done. Let's take a look at this. What's different here? Oxygen with a hydrogen on a carbon, alcohol. What do we have here? Ooh, N moles of ethylene oxide. And what do you get? You get a polyether alcohol. Remember, the hydroxyl group goes outside the bracket, not inside. It's a common mistake students make on test 2. What's my R group? Well, it's cyclopentane ring. You don't break carbon-carbon single bonds. I'll have my oxygen with a bracket, CH2, CH2, close bracket. What's N? 7. And there you go. Oh, this was so much fun. Let's do a real fancy other one. First of all, let me give everybody time to copy that down. Like I said, I have a super fast mouse wheel finger. Everybody got that copied down? And the answer is not yet. And the answer is yes. All right, let's do a real fancy one. Now, this is just an R group like methyl or ethyl, but it's got 9 carbons and a lot of hydrogens. That's called a nonal group. Oh, wait, we got a benzene ring. But will benzene react with ethylene oxide? And the answer is no. And with that, I'll let you try this one on your own first. Then I'll do it. Time for Dr. White to give you a hint. You like the hint? All right, if you're done, give me a thumbs up. Give one person a little more time to catch up. I think everybody's caught up. By the way, later this semester, I will talk about ketchup and mustard too. Organic chemistry at work. All right, let's do this. All right, what do I have here? Well, I've got a benzene ring. That's not going to react with ethylene oxide. I have N moles of ethylene oxide. This is an R group right here, like methyl ethyl. That's not going to react. But ooh, carbon with a hydroxyl group on it, that's an alcohol, and that will react. And what do you get? You get this polyether alcohol. Poly means many. Remember, the hydroxyl group is outside, not inside the bracket. What's my R group? Well, someone already told us. So I'm going to rewrite it. Then I'll have this right here, bracket O, CH2, CH2, close bracket. What's my N? 9, and the hydroxyl group on the outside of the bracket. And there you go. And this is the molecule you make. Now, a while ago, I mentioned I'll be doing it more and more. You should be asking the question, why am I taking this course? And the obvious reason is you want to get a good grade so you can get into a program or into a school for your major. But why should you learn this stuff? And that's the question I'm going to answer right now. Oh, I should mention, caveat, that more and more I'll be talking about things. In no way am I taking a moralistic view. It's just organic chemistry. And this is one of those times. If we look at the molecule you just made, it's got a trade name. This is not a common name. It's not a IUPAC name. It's a trade name used by various manufacturers. And it's called nonoxyl 9. Why? Because I have nonal group, OL 9, nonal alcohol, and I have 9 moles of this repeating ether, polyether. All right, thumbs up, people. You see Wiki? Thank you. All right, now here's the way they have it drawn. It's the same thing. 9 carbons. That's every bend in a line is CH2, so this is HCH2s and CH3. My benzene ring and the pair position 1, 4. My polyether, this is CH2, this is CH2. Notice N is 9 and alcohol at the end. And now you're probably saying, so what? Well, let's take a look at what this molecule is mainly used for. And it's a spermicide. If you go either for condoms, if you go to, time out so you can see me. If you go to your local big box store, and I'm not saying you should, but if you do, and this is something Dr. White does a lot, because I'm an organic chemist and I like to learn things, I pick up things and look at labels. If you go to your local big box store like Walmart or Target, or as my friends say, that French store, Target, and pick up a box of condoms, if you look at the lubricated condoms, prophylactics, you'll see they have a spermicide. And if you look at the ingredients, it's nonoxyl 9. Now, how that works, don't know. I'm an organic chemist. I just showed you how to make it, but I think I read somewhere it somehow inhibits the mobility of sperm. Don't quote me on that because I'm an organic chemist. That's not my area of expertise. Now, if we go back to this, it's also used as spermicide and cervical barriers. And the one thing when I first looked this up for other uses, I found out it's used as a lubricant in shaving cream, which explains why my face hasn't gotten pregnant yet. Now, another interesting thing is the surfactant. This is used in a lotion if you have poison ivy, which luckily I never have, and it helps break up or remove a certain oil or chemical that causes the rash and the itch, from what I've been told. Like I said, I haven't. But anyways, its main use is as a spermicide in condoms. Now, one of the things I'll teach you more about are surfactants and polyether alcohols made with ethylene oxide are surfactants. And these are molecules that interact at the surface of different things like your skin and dirt and water and other things too. And I'll talk more about it. I spent many years in the chemical industry where the companies I worked for made surfactants. It's a multi-billion-dollar industry in the United States. I have a number of patents that are based on surfactant molecules. An example of a surfactant that I'll talk more about is soap, how you clean your hands, and also fabric softeners, how you get your shirts and whatever nice and soft from the dryer or the washing machine. Oh, public service announcement. I'll explain why later in the semester. If you use a fabric softener, one, use the sheet instead of the liquid you pour into the washing machine. It's much more effective. And I'll tell you an interesting story about the sheets in Procter & Gamble. That's true. I found out one day at a bar with some people I took out from Procter & Gamble. And also, have you ever had where your towels aren't working as well as they used to? They're getting old. You say, oh, they're getting old. They're not working well. Working well meaning absorbing water. That's because it's got too much fabric softener. To get them back to normal, just wash them once or twice without using a fabric softener, and they'll have the same absorbency. In the industry, that's called re-wet. And if we look at the slides, we're at the end of chapter 8. All right, listen up. I noticed on the schedule, I goofed up on test 2 again, like I did 1, and I'll be moving it a week further down the line because it's supposed to be next week. And there's no way I'm going to cover ketones in 1 week. All right, this Wednesday we'll do alcohols. Next, let's do it on next Monday, Wednesday, we'll do ethers and epoxides. So keep up. I'm speeding things up, putting my foot down and accelerate a little, but I always do that this time of the semester in this class. All right, it's new chapter time, which means that it's, hold on, I haven't used this in a while. It's new functional group times. Now, I have a very serious warning about this chapter. If Dr. White looks like he's having way too much fun, I am. How many of you have heard of comfort foods? You know, when you're not feeling good, you eat it. Mine are most dangerous are Lay's sour cream and onion potato chips. And salami sticks too, good kosher salami stick. Oh. But anyways, Dr. White has comfort functional groups. When I'm not feeling good, I'm blue, and I want to pick me up mentally, I'll think about these functional groups and they make me happy. And these functional groups I worked with getting my PhD, my first and last patents, I use these functional groups. And by the way, Mother Nature loves them too. So what are these new functional groups? Well, let's get to it because Dr. White's going to have a lot of fun. And I'll get to introduce you to some old friends of mine. And new functional groups we'll be talking about. And let me just check. Everybody see chapter 9 on their screen? Thank you. The new functional groups are aldehydes and ketones. And Dr. White loves aldehydes and ketones, so does Mother Nature. My PhD thesis dealt with aldehydes and ketones. And like I said, my first and last patent I was able to get because I could do things with aldehydes and ketones nobody else could. So what's an aldehyde? Well, an aldehyde is a carbon double bond to oxygen that also has on it R and H, another way of writing it. And this is an aldehyde. And sometimes my software will do it, and I might do it. I'll write it like this, where the bend of the line right here is a carbon. And I try and stay away from that, but once in a while I'll do that. So an aldehyde, R group on a carbon double bond to oxygen, and that carbon has a hydrogen also, 4 bonds to carbon. 1 double bond makes 3, hydrogen makes 4. Now, as I said, there's another way. My software likes to draw it this way. And there's a carbon there every bend in the line. Now, sugar chemists like to draw their aldehydes this way. That's the same thing, because I could also draw it showing the bond like this. I don't. I think this looks cooler. And Dr. White loves being a cool dude. So in my class, I'm going to write it this way. But on a test, if you write it this way or this way, it's totally acceptable. And this is an aldehyde. Now, what's a ketone? Well, it's similar to an aldehyde, except here you have carbon double bond to oxygen. And I see a question. Question is a sister trans? Well, that's a good question. Let's find out. Now, if you look at the aldehyde, like here, I have 1 carbon to double bond, or 1 atom of the double bond. Where's the other groups on the oxygen? There aren't any. So in this case, this double bond, there are other double bonds I'll show you, but this one, there's no cis-trans isomerism. It just exists as an aldehyde. And you'll see that when we get into nomenclature today, which we will. All right, ketone. And by the way, ketone is not spelled with a Y here, even though it's pronounced like ketone. Anyways, I see another question. You can draw it different ways, and that's a good question, Joshua. And now you know. No, it wasn't a stupid question. It was a good question because now you know the answer. All right, let's move on to ketones and aldehyde, or ketones. A ketone is a carbon double bond to oxygen and has 2 R groups on it, R and R prime. And sometimes I'll show the bond angle this way. More likely, I'll write it this way. And you actually could have written it this way. Those are all ways you can write a ketone. And a ketone Also, my software will like to draw it this way. And where there's a bend in the line, there's really a carbon. Now, ketone has R and R prime, and that means they're both carbon and hydrogens. Where in an aldehyde, R prime is a hydrogen. So they're very similar, and you'll see a lot of the chemistry, ketones and aldehydes, are similar. Now, one of the ways to denote a ketone and aldehyde is like I have here, R and R prime. When R prime is hydrogen, it's an aldehyde. When R prime is something with carbons, alkyl meaning alkanes or benzene ring, aryl. And another way I'll do this, you'll see when we get into reactions, I'll do it this way. When R prime is hydrogen, it's an aldehyde. When R prime has carbons, it's a ketone. And remember, this is an aldehyde. This is a ketone. So now we have these two wonderful functional groups, and the question is, how do you name them? But before we do that, there's something very important I want to talk about. And I'll reveal something very personal now about Dr. White. And that's the carbonyl group. The carbonyl group is carbon double bond to oxygen. It's not a functional group. Well, look in the next, though it's called a group, carbonyl group is not a functional group. And I think it's time for Dr. White to get subtle. You should know how to describe with words and a picture what is a carbonyl group. And how do you do that? Carbonyl group. Carbon, double bond to oxygen. And here it is in words. Carbonyl group. Carbon, or you can put down carbon atom, double bond to oxygen or oxygen atom. You should know this. This is probably one of the most important things to me personally in all of organic chemistry. What is a carbonyl group? Carbon, double bond to oxygen. And you should know how both to draw it and how to write what it is in English or write it out. Carbonyl group, carbon, double bond to oxygen. And the personal thing I wanted to share with you right now is somebody asked me, what kind of chemist are you? And if I was totally honest, in my heart of hearts, the only thing I could answer is, I'm a carbonyl synthetic organic chemist, because the carbonyl groups are wonderful. Now, carbonyl group, which is not a functional group, are found in many functional groups. The first ones I'm teaching you are ketones and aldehydes. Other functional groups, they exist too. If you look at your skin, it's got carbonyl groups in it. So does your food and a lot of other things too. And we'll be talking about that during the semester. So you should know how to describe with words and drawing what is the carbonyl group. And the carbonyl group is carbon, double bond to oxygen, and carbon, double bond to oxygen. You put two lines, say it's bonded to other things too, which is what I have here in Technicolor. And like I said, it's not a functional group, just like a methyl group is not a functional group, but it's so important in organic chemistry that it was given a special name, which I totally support. All right, let's look at how do you name an aldehyde? Well, let's take a look at an aldehyde. Now, if we look at the molecule I just drew, and I haven't asked this in a while, and I should, everybody see it on the screen? Nomenclature, thank you. All right, now if we look up here, what's different? Ooh, oxygen double bond to carbon, otherwise known as a carbonyl group, with carbons and a hydrogen. That's an aldehyde. How do you name aldehydes? Find the longest chain, which includes the aldehyde, otherwise known as the carbonyl group, carbon, and this is the carbonyl group carbon, the carbon double bond to the oxygen with the R group and that. And if we do this, we have 1, 2, 3, 4. And name that as an alkane, and that would be butane. And then drop the E at the end of the A and E, butane, and replace it with an AL, butanal. Now, because the carbonyl carbon rocks in an aldehyde, this carbon is always number 1. No exceptions, I can't think of one. Therefore, you don't have to put that down. And the rest of the alkyl groups are numbered like you would on a chain, and you can't have a carbonyl group in a ring, so that's how you do carbonyl groups. Let's do another one. And the question would be, what's the IUPAC name for the following? On test number 3, it's number 2, there'll be about 35 points. Nomenclature, we'll be doing more reactions, but still you need to know nomenclature. I'll do this one. What do we have that's different? Ooh, carbon, double bond to oxygen. It's carbon, double bond to oxygen as a hydrogen, as carbons. This is an aldehyde. And how do you name it? Find the longest chain with the carbonyl carbon. That's the carbon double bond to the oxygen. That's 1, 2, 3, 4, 5, or 5. 5 carbons is pentane. It's an aldehyde. Drop the E, add AL. And you don't need a number because this is always going to be 1. That's 1. This is 2. That's 3. That's, oh, look, it's your old friend, the methyl group on carbon 4. And that would be 4-methyl pentanal. And that's how you do it. And if I look at my clock, it's about ready in about 20 seconds to take a break. So I'm going to have you take a break 20 seconds early. Or is it changed already? Not yet, about 20 seconds. I'll take a check. I'll see you at 1:55 because Dr. White's going to get up and stretch. I'll see you in 5. Or as Arnold would say, I'll be back. All right, let's get back to work, everybody. We're talking about one of my comfort. I have actually another one I'll talk about later in the semester, but aldehydes and ketones are a comfort functional group for Dr. White. Now you really know I'm an organic chemist. All right, we're talking about how do you name aldehydes. And you find the longest chain, carbon chain that includes the aldehyde, otherwise known as the carbonyl carbon or carbonyl group carbon. Name that as an alkane, which you know how to do. Drop the E at the end of the alkane, ANE ending, and replace it with an AL. The carbonyl carbon is always number one, so you never put a number like with a double bond you do, or an alcohol. With this, you don't. And then the other rules for IUPAC substituents are the same. So I better let you have a try at one. And what would be the IUPAC name of this molecule? Have fun. And when you're done, give me a thumbs up. For those of you without your video on, use the emoji or come up with some other inventive way. Oh, I see a question. Oh, I see a thumbs up. All right, let's do it. How do you name this molecule? Look for what's different. Ooh, oxygen, double bond to carbon. That's different. Remember, look for what's not carbon, what's not hydrogen, what's not a carbon-carbon single bond. And this gives the carbonyl group is like a flashing red light in your rear view mirror. Hopefully it's a fire truck and not a police car. But anyways, or they're after someone else. And this is an aldehyde. How do you name aldehydes? Find the longest chain with the carbonyl carbon, this one. 1, 2, 3, 4, 5. That would be one chain. 1, 2, 3, 4, 5, 6, 7. I hope you all agree 7 is greater than 5. That would be heptane. It's an aldehyde. Drop the E and add a L, heptanal. Am I done? No, as soon as I say heptanal, that's all spoken for. But oh, look, Dr. White's favorite group, one of them, and it's a T-butyl group. And what carbon? Carbonyl carbon is 1, 2, 3, and that would be 3 T-butyl or tert-butyl heptanal. Now, word for a little warning. Aldehydes, AL ending. Alcohols, OL ending. On test number 2, make sure you print clearly. You don't want Dr. White guessing, is that an O or an A? Because you might get it marked wrong. So on test number 2, please make sure you write clearly your O's and A's. Oh, let's do another one. These are fun. And what would be the IUPAC name for that molecule? And when you're done, give me a thumbs up. And you can find the thumbs up emoji in the lower, should be lower right-hand side of your screen. Or all right, I think everybody's done. Let's take a look at this. What's different? What's not a carbon-carbon single bond? Carbon oxygen. Ooh, carbonyl. It's got a hydrogen and it's got carbons on it. And this is an aldehyde. How do you name aldehydes? Find the longest chain with the carbonyl carbon double bond to oxygen. In this case, 1, 2, 3, 1, 2, 3, 1, 2, 3. Longest chain is 3, and that would be propane. It's an aldehyde. Drop the E, add Al, propanal. And carbonyl carbon is 1. You don't put that there. You don't ever put 1 propanal. I'll take all points if you do. And what do we have? As soon as I say propanal, that's spoken for. And look what we have on this carbon. 2 methyl groups. And how do we say 2? Di, and it's methyl. And as soon as you see di in front of a substituent, like a methyl group, you need 2 numbers, even if they're on the same carbon. This is 1, this is carbon 2, so this would be 2,2-dimethyl propanal. All right, now, there's a special aldehyde that you've already seen, but I will talk about, that the IUPAC people decided, oh, we're not going to get those organic chemists to change. They've been calling this compound this name for eons, so we'll make it the IUPAC name. And that's this aldehyde, where R is a benzene ring. And this is called benzaldehyde. And the next time you smell maraschino cherries, you know, those red ones that glow in the dark, I think they're radioactive, but I love them. Or if you smell Dr. Pepper and the cherry in Dr. Pepper, or if you smell almonds, like marzipan, almond paste, what you're smelling is benzaldehyde. Unfortunately, we couldn't do the aromatic lab you handed in a while ago in the actual lab, but if we had, in the lab, I'd pass around, I have some paper towels, squares that I put benzaldehyde on, you smell it. And when I smell it, I can smell both cherries and almonds at the same time. My brain is multitasking. And it can do that too. Now, there are two types of skills in nomenclature. One is here's the structure, give the IUPAC name. The other is here's the IUPAC name, draw the structure. Let's try one. I'll do one, then I'll let you have one. And the question is, what's the structure, or draw the structure of this compound? How do you do that? You start from the right and move left. Ooh, Al ending. Al ending means aldehyde. If I can spell it. If this were an E, nonane, would be 9 carbons. Now, one thing I mentioned earlier with alcohols, Dr. White likes to put his functional group on the right. If you put yours on this side, it would be correct also, but I don't. Good habits I don't break. So I have my nonanol. The carbonyl carbon is 1, even though you don't write it. And then isopropyl on carbon 3 to 3. And then there are 4 bonds to carbon. So I can put in my hydrogens. And remember, it's your responsibility. If I make a mistake, correct me. And that's 3 isopropyl nonanol aldehyde. And I'm going to let you try one too. And there you go, 2-ethyl hexanal. And this, yes, this is an Al. Draw the structure of the following molecule, 3 points each. You're doing organic chemistry, and it's not that bad. And see people still working. I see people almost done. All right. Everybody, say hello to my old dear friend, 2-ethyl hexanal, that I was able to do stuff with this compound that nobody else did, and led to my first patent and also a couple others too. So how do you decode it to know what to draw? You start this way and you say, oh, Al ending, aldehyde. And if this were an E hexane, that's 6 carbons. At the end, we have my carbonyl group, carbon double bond to oxygen, which has a hydrogen and carbons. And carbon 2, we have an ethyl group. This is 1, 2. And there you have 2-ethylhexanal. Ooh, let's try one more. And it's the name usually people don't use. They use a common name, which I'll teach you later on. Why don't you draw the structure for methanol? This might be tricky. All right, let's do it. Well, Al ending tells you aldehyde. And if it was Z, methane is one carbon. So what do? I do this. And this is a structure. It turns out in aldehydes, R can also be hydrogen. And this is the simplest aldehyde. And a little later today, I should get to it, I'll teach you another name for this, for methanol. And also I'll teach you some things you should know about it too. And that's how you do aldehydes. Let's do ketones. Now, ketones are a little different. First of all, if it's acyclic, find the longest carbon chain, which includes the ketone, meaning the carbonyl carbon, and name it as an alkane. But unlike an aldehyde, you can have cyclic ketones and name it as a cycloalkane. By the way, Dr. White and Mother Nature really love cyclic ketones. And drop the E at the end of the NAE name, alkane or cycloalkane, and replace it with the letters ONE. For some reason, I never say one, I say ONE. And then the carbonyl carbon in a alkane or chain is always given a number, and it's the lowest, highest priority carbon, the lowest number. And if it's in a ring, the carbonyl carbon is always number one. And the rest of the substituents are the same rules you've already learned for substituents. So let's take a look at this. And if we look at this molecule, what's different? Ooh, carbon double bond to oxygen, carbonyl. I've got carbons on this side, carbons on this side. It's a ketone. How many carbons are in the longest chain? Don't know. One, that includes the carbonyl carbon, 2, 3, 4, 5, 6. That would be hexane. It's a ketone, drop the E, add ONE, hexanone. And now, unlike aldehydes, notice this is on what carbon? This is carbon 1, carbon 2. If we went the other way, this would have a much higher number, and it always has the lowest. So that would be 2-hexanone. Now, just to show you why that number is important, you could have this molecule, which is an isomer of the one I just drew up here. And this also is a ketone. carbonyl carbon double bond to oxygen with R groups on it. Now here the longest chain also is hexane. I'll drop the E, add ONE, but now this is on carbon 3. So this would be 3-hexanone. And that's important why you need to do numbers. Now, if I were to have this molecule, and the question is, how do you name that? And I'll do that, and then I'll give you some to have fun with. What's the longest chain? I have one, and it has to include the carbonyl carbon, carbon double bond oxygen, 2, 3, 4, or I have 1, 2, 3, 4, 5, 6, 7, 8, 9. And I hope you all agree 9 is greater than 4, so that's the alkane nonane. But it's a ketone. And therefore drop the E, add ONE. Next is acyclic. I need a number. This is carbon 1, 2, that would be 3. So it'd be 2 nonanone. And then I have your good buddy, the methyl group, on carbon 3. So that'd be 3-methyl, 2-nonanone. Who say that 5 times quicker? No. Again, what's the longest chain with the carbonyl carbon, carbon double bond to oxygen, and it's 9, nonane. Drop the E, add ONE, nonanone. What carbon is it on? Carbon 2, and we have a methyl group on 3. All right, your turn. What would be the name of that molecule, iupactane? Well, I see one person just gave me a thumbs up. Thank you. More people. I see one person just, all right. Even someone gave me a high five. All right, let's take a look at this. What's different? What's not carbon? What's not hydrogen? What's not a carbon-carbon single bond? Ooh, oxygen double bond to carbon. And carbons here, carbons here. In this case, R and R prime are the same. And we've got a ketone. And how many carbons are in the longest chain with the carbon double bond to oxygen, also known as the carbonyl carbon? 1, 2, 3, 4, 5. That'd be pentane. Drop the E, add ONE, pentanone. And now what carbon is it on? Well, if you start from either side, it's on carbon 3, so it's 3-pentanone. Ooh, let's do another one. And there you go. Have fun. And it should be. Give the IUPAC name for the following. Oh, excuse me. For those of you who finished early, please be patient. I try and give everybody time to finish. All right, I think everybody's just about finished. Let's do it. All right, look at what's different, what's not carbon, what's not what's not what's not hydrogen, what's not a carbon single bond. Getting ahead of myself there. Carbonyl group. And it's got carbons on this side, carbons on this side, and that's a ketone. How many carbons in the longest chain with the carbon double bond to oxygen called the carbonyl carbon? Don't know. 1, 2, 3, 4, 5, 6, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I think 9 is greater than 6. So we have nonane. Drop the E, add O-N-E, known and known. What carbon is the carbonyl carbon? Going this way, 1, 2, 3. The other way would be 1, 2, 3, 4, 5, 6, 7. 3 is smaller than 7. So it's 3 known and known. If that's 3, this is 4. That's 5. As soon as we say that, oh, we have not 1, but 2 alkyl groups. And notice we have an ethyl on carbon 4, methyl on carbon 5. So that would be 3 ethyl. What am I saying? 3, 4 ethyl, 5 methyl, 3 known and known. Wow, that's an impressive name. Now, if you put the 5 methyl first, I would give you full credit because I'm not holding you to the alphabetical rule. And that's how you do acyclic ketones. Let's go to this molecule. Now, Dr. White's really happy because I like cyclic ketones. And if you look at this molecule, up here I have a carbon, I have carbons here and here. So what that really is this, but these R groups are connected together in the ring. So how do you name this? How many carbons longest chain? Well, we don't have a longest chain. We have a ring. 1, 2, remember every bend of the line is carbon. 3, 4, 5. This would be as a cycloalkane. Don't forget the cyclo. Pentane. Now you drop the E, add O-N-E, and this carbon is always going to be 1. So I'm done. Cyclopentanone. Now, when you have substituents, If we look at this molecule, what do we have? Ooh, what's different? Oxygen double bond this carbon, carbon's here and here. It's a ketone, which I forgot to write up here, but I'll write it now down here. Carbonyl, carbon double bond to oxygen with carbons, just so happens in a ring, R and R prime are connected. So how do we name that? How many carbons in this ring? And there's 6 bends, so that's hexane. No, it's a ring. Cyclohexane. It's a ketone, so I'm going to drop the E and add ONE, cyclohexanone. This is always number 1, and you don't need a number. Therefore, this is 2, this is 3. N-propyl. And that's 3N-propyl cyclohexanone. And that's how you do cyclic cyclic ketones. By the way, this will never be on a test, but there are other ring systems I haven't taught you in this class because you won't encounter them. Dr. White has. And it's time for me to introduce you to a really good old friend of mine who helped get my PhD degree. And this is called a 222 bicyclooctane ring. And this is 222 bicyclooctanone. And I used the other one that also had either an aldehyde or a ketone here. And that was molecules I made for my PhD thesis. But anyways, now that I brought back an old friend, Dr. White, really feels good. But I better help you learn how to name this stuff. And what would be the IUPAC name for the following molecule? All right, everybody just about done? Going once, going twice, let's do it. All right, if I look over here, I look at this and say, oh, I've got a ring. Well, that's just carbon and hydrogens. But I have a carbon double bond to oxygen, carbonyl. It's in a ring, so I can think of that as R and R prime, and they're connected together. That's a ketone. It's a cyclic ketone because it's in a ring. How many carbons in a ring? 1, 2, 3, 4, 5. Pentane. It's a ring, cyclopentane. And you drop the E, make it that. ONE, because it's a ketone, cyclopentanone. This is carbon 1. This has to be 2, and that'll be 2-methyl cyclopentanone. Now, there are 2 skills, and the other skill is a nomenclature. Here's the name, draw the structure. We did acyclic. Let's try a ring. And that'd be 4N-butyl cyclohexanone. I was going to put P, but we already did our 5-member ring above. So why don't you draw the structure? Remember, you start this way, and that will help you decode it. Go. If you see me yawning, I got up way too early this morning. I was already working by 4:45, which means I should fire up for you people. All right, let's do this. How do you decode this? You start from the right, move left. O-N-E-N-D, ketone. Hexane, 6 carbons if this were an E, but cyclohexane, it's a ring. And it's a ketone. You have a carbon double bonded to the carbon in the ring. This is always going to be 1. On carbon 4, I have an N-butyl, and this is carbon 4. And you can make it going to the right or the left. It's the same thing. And this is 4N-butyl cyclohexanone. Now, switch is off, but do I have time? I do. It's time for a nice Dr. White story. True story. Hope you like my stories. All right. After I was a postdoctoral fellow at the University of Illinois, Chicago, otherwise known as Circle, when I went there, even though they don't like being called that anymore. I got my first job in industry. I was working for Axochemy, now it became AkzoNobel. They sold off that division that's called now Nourion. Well, anyways, so I'm living in Chicago. I had an apartment about a block and a half from the lake. It was nice, not far from Loyola University on the north side. The one problem was being near the lake and also were a lot of big apartment buildings, parking was hard. And so luckily through politics, and I'll talk about that story another day when I can cut it out of the video, I was able to get and rent a garage from this apartment building where there was 3 apartment building and one of the people who owned an apartment didn't own a car. So I could rent that from the owner of the building. Well, at this job, they had flex hours, which was quite nice because I lived on the north side of Chicago and I had to go all the way by Brookfield Zoo, which was take the outer drive to the Stevenson, get off at First Avenue, and there I was. Well, to miss rush hour traffic on the outer drive in the Stevenson, I could start at 7 in the morning, which means with everything, I'd go to my garage about 6 in the morning. And back then they didn't have the laws they have now. And this was in an alley, in an apartment in Chicago. And often I'd find somebody's dog had left me a present right in front of my garage door, which was not a pleasant way to start your morning because you have to move it. Otherwise you drive over it. But anyways, so where I worked, I was in a group of about 12 people, the product and process development group, which about 2 years later I became section head of. But anyways, Friday afternoon, we'd leave because of flex time at 4. Well, about 3:30 Friday afternoon, we'd all be in one of the labs and just shooting the breeze, talking about things. And one day I was complaining, I'm getting tired of this. I got to clean up somebody's dog poop all the time. And one of the older chemists said, don't you know about methylnonyl ketone? And that's a common names I'm not going to teach you. There are a lot of other common names I'm not going to teach you. And that the IUPAC would be 2-undecanone, which I haven't asked you to learn up to 11 carbons. 11 is undecane. But anyways, said you can get that from the sample room. And I said, why should I get that? Well, that's the active ingredient in dog repellent. Doesn't hurt them. They just don't like the smell of it. And for those who don't know, any company that sells chemicals has what's known as a sample room. And the sample room sends to customers or people in the company are working with company chemicals samples. And the samples can be anywhere from 4 ounces up to 5 gallons, depending how big of a customer you are. If you're working in research for that company, a lot of times you would get a 5 gallon bucket of chemical. So I called over to the sample room and said, can you send me a quart bottle of methyl ketone? Sure. So next day I got it over. I took home some eyedroppers in the bottle. Now, what you buy in the store for dog or cat repellent and other animal repellent is only about 3 to 5% active. That means the methyl ketone is only there 3 to 5%. I had 100%. So I took my eyedropper and put a line or two right in front of my garage door and a couple feet out. Guess what? Next morning, no dog poop. And forever afterward, when it rained heavy, some of it washed out, and I'd put another line or two with my eyedropper. And that's my methyl ketone story. In fact, when I moved to my house now, I had this one person who would leave presents, and the sidewalk, I put a couple lines of methyl ketone. I still had friends at that company. I got another quart, and guess what? No dog problem. They don't like the smell of it. It doesn't hurt them in any way. Now, there are two common names I would like you to know. The first one is the simplest aldehyde is called formaldehyde. Nobody ever calls this methanol. It's called formaldehyde. In Alaska, I worked at a company that was the world's largest producer of formaldehyde in the United States, and I think even the world. And this is formaldehyde. And I'll talk about this in a little while because there's some things I need to talk to you about. Now, the simplest ketone this would be 2-propanone. Oh, and the ending, nobody ever calls it that. They call it acetone. And a lot of you might have acetone in your home. Wait a second, I don't have acetone. Yes, you do. Nail polish remover, there are two types. One is acetone. The other I'll teach you later on is called ethyl acetate. And acetone is a liquid. If we were in the lab working at ECC, you also use acetone in an organic chemistry lab to clean glassware, and we use a lot of it. When I was in grad school, I did so many reactions and clean glassware, I'd go through anywhere from a half to a gallon of acetone in a day. I mean, that's a lot, but I did a lot of stuff. I wasn't the only one in our research group. We were expected to get busy. So you should know, and it's a common name. So that means on a test, I will never say, draw this, what's the common name for the structure, but I will ask you, like, draw the structure for acetone, draw the structure for formaldehyde. All right, I may go a minute or two over in our break, and I'll still give you the break. But this is something important I want to do now, talk about now. Formaldehyde can be a very dangerous chemical. My last patent, I used it. When handled safely, it's not dangerous. When not handled safely, it's extremely dangerous. How many of you remember Hurricane Katrina? I should ask that because some of you might not. But anyways, back, I forgot the exact year, there was a major hurricane that hit the Gulf of Mexico states, especially New Orleans. If you can remember the horrific pictures of people trapped at the Superdome in New Orleans running out of food and water, it was sad because the president we had then didn't do anything for a while. And then they finally got this great general down there, Honoré, I think he was a general then, and he straightened things out real quick, which thank God for those people, he did it. But anyways, afterward, because so many houses were destroyed and apartment buildings, the government, US government at the time, ordered from mobile homes lots of mobile homes. Well, because of the uh, people started living in them and they started getting sick. And I found about this by reading a newspaper stuff. And also because there was a very brave lady named Becky Gillette who went and found out on her own. I never asked Becky what made her look at this. One of these days I'll have to email her and ask her uh, that formaldehyde was in very high levels in the trailers. Well, where does that come from? What you don't know, but I worked for a company that used formaldehyde to make a resin. Resins are a fancy name for glue. And one use, I worked in the area where we held sand together to make molds, or actually our products made molds for foundries, like your car engines. And I actually went to GM Saginaw plant and also Ford uh, Windsor plant, because the products I invented, they used them on. And if there was a problem, I went to that plant to help them solve it. I'll tell you that later when we get to polymers. Well, it turns out, Becky, first of all, formaldehyde makes a resin that holds wood together, a glue. And where do they do that? To make plywood and particle board and oriented strand board, all wood products used in construction. Well, at the time, and this is conjecture on my part, but I'll bet on it and I'll explain why in a little while. If I say I bet on it, I know I've already won. And that is because of the shortage of wood, plywood in the United States and particle board to make trailers along with houses, because a lot of it was used to board up windows in the New Orleans area and that whole Gulf area before the hurricane hit. These mobile home companies went to China. And there's certain laws called OSHA rules that prohibit exposure to certain chemicals. In the United States, there's an OSHA law of 100 ppm. I think it's even been lowered since then, exposure to formaldehyde. So that means the kind of products you sell to make plywood has to be very low in what's called free formaldehyde. Well, in China, they don't have anything like that. And to this day, they don't. And therefore, their wood products were probably high in formaldehyde. Well, having that formaldehyde got a lot of people sick. Old people had very serious health problems. I'm not sure if any old people died. I know some pets died. I think some people, and it became a very serious problem. And even after that, if people had bought new furniture or new kitchen furniture, they'd get sick from the formaldehyde coming from that. So Becky found this out. And when I found out, I called her. I said, I'm a world expert in formaldehyde and its uses. However you need me, I'll help you anyway, free, because I was consulting then. And I told her and I helped her. And one of the things she asked me to do was, at that time, with the new president, Obama, taking over, to write a letter to him and also to the head of the EPA to consider new laws to protect people from exposure to formaldehyde. About that time, and they've always been a leader in environmental concerns, California has put in a law, and it was the Air Resource Board. And the United States was considering adopting their law. And so I wrote to both the president and also the administrator of the EPA, the head of the EPA, about that. And I wasn't the only one who did that. And luckily they've adopted it, even though a couple of years ago, 60 Minutes did an expose how Chinese companies were certifying it. It met the, not OSHA laws. I'm drawing a blank what the acronym for that is. After class, I'll remember it. But anyways, met those laws, and they weren't. They were just faking it. And but anyways, what I do want to tell you is the following. Let me. And And this is Becky's site. It's not as active now. You can see some of the dates are older about some of the horror stories, people getting sick, very sick. But the thing I want to show you is right here, and I don't get any kickback, you can test for formaldehyde your own home. If you know anybody who have new chilled babies and they went out and bought new furniture, and if it wasn't solid wood, if it was particle board, which most people buy with a veneer on top, it might be giving off formaldehyde. And actually, I talked to some people whose children were made sick from that furniture, not only, but this company, now I've never used it, but a number of my students have, they have a test kit. It's $39 and maybe a little higher now, because like I said, here's their website. And they send you a kit, and it's got this badge. You take it, put it in a room for 24 hours. They give you a mailer, you send it back, and you can choose, do you want either in the US mail or email the results, and they'll let you know is it hazardous or not in that room. Now, when Becky started fighting the EPA and FEMA over the toxic trailers and President Bush, they fought back and said, your numbers aren't accurate and all that. And she was using this company. And EPA went and retested everything. And luckily, the people who did that were honest. And they said, no, her numbers were accurate, which means this company gives accurate measurements. So I just wanted you to know about that. Now, another thing that happened a number of years ago, before, I think it was after Hurricane Katrina, Chem 170 student came to me and she worked in a hair salon, said, have you ever heard of the product Brazilian blow up? No. Well, is it bad? Some of us are getting sick from it. Well, I'll look it up. And it just so happened that California and Oregon EPA put out a warning that this product had a lot of free formaldehyde, which means people are breathing it in while using it. And what it did is it straightened out hair. If you notice, I still have a little curly hair left. But anyways, for people who have real curly, kinky hair and they want it straighter, this does a great job, except it's high in formaldehyde. And eventually the outcry, they changed their formulation, but salon owners and their patient and their wasn't patients. I go get my hair cut, I'll make an appointment. I'm a patient now, but their customers were getting sick. I told after I looked it up and saw the amount of free formaldehyde in the product that helps straighten the hair with that formulation, I just said, don't use it, stop using it, or open all the windows, get some fans. I don't think they're going to buy fume hoods and get a lot of fresh air if you're going to use it. And it's been changed. Now, I went a little longer than normal. Let's come back in 5 minutes. We'll still end 10 minutes early from the prescribed things. I'll see you in 5. All right, I better get started. Ring, ring. Back to school. All right, everybody back. Let me just quick public service announcement from Dr. White. And that is one, don't forget if you have any questions, my office hour tonight from 6 until 7:15 on Zoom. So that way you don't have to drive to ECC. And normally if we'd been at class, I'd have my office hour right after the lecture today. But this way, I made it later in the evening in case some of you are working. If you ever need to see me at a different time, let me know and we'll work something out. Because with Zoom, I don't have to drive to ECC either. Now, one more thing I forgot to mention about formaldehyde. As I mentioned, I was working with Becky Gillette. What a brave woman. I got to talk to her and get to know her. She was a member, I think she might still be, of the Sierra Club. And with her own money, she investigated and found that and saved a lot of people because of her, what she did. Well, anyways, along that time, the Select Committee of Congress, then it was under Democratic control, and Henry Waxman, the representative, was chairman of that committee, was going to have a hearing with all the mobile home manufacturers who made these trailers that got a lot of people sick. So Becky contacted me and said, could you call this gentleman? He's the head investigator for the Select Committee of Congress under Waxman, Representative Waxman. He has questions he wants to learn about formaldehyde because they're going to bring the owners of these trailer companies in and have a public on TV, meeting and find out the answers. So I said, sure, I'll help them. So I talked, I don't remember his name. I talked to him about 45, 50 minutes. Then at the end of that, I said, could you do a big favor for me? He said, what? I said, could you ask Representative Waxman, Congressman Waxman, to ask the owners one question? He said, what's the question? And I said, ask them, where do they buy the wood for those trailers? And immediately said, we can't. And immediately I knew he knew what was the problem. And the whole investigation on TV was a PYA, protect your you-know-what, to make them look what Congress is doing. They weren't doing nothing. And I realized I just wasted 15 minutes of my time. Well, I learned a lesson about Congress, that sometimes their show for investigations on TV are just the PYA. Anyways, enough of me personally. Let's move on to ketones and aldehydes. And again, you should know the structure of formaldehyde is this aldehyde, and the structure of acetone, which is nail polish remover, is this ketone. Oh, by the way, did any of you happen to drive by a gas station and think that gasoline has ethanol? It's an alcohol. Did you happen to go into a liquor store, or if you're old enough, and buy some good vodka, think it's got ethanol in it? Remember, organic chemistry is all around you, and it won't hurt to think about it. All right, let's do a quick thing. One of the reasons why am I learning about this? Well, aldehydes and ketones are in nature. Now, benzaldehyde, you already learned that structure and the fact that what it smells like, excuse me, getting all choked up over one of my favorite smells. And cinnamaldehyde, you learned, is this trans aldehyde. It's got a trans double bond. And vanillin, you already looked up the structure. Well, let's look at raspberry ketone. If you like raspberries, and I do, what's that? Let's take a quick look. All right, where did I hide you? If you look on your screen, everybody see the molecule? Hopefully you do. And remember, every bend in a line is a carbon, every end of the line is a carbon. And here we have a ketone, methyl group, carbon, 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 a benzene ring, and a hydroxyl group. So, and this has got the common name raspberry ketone, because this is what gives raspberry their taste. And it's got 3 functional groups: ketone, aromatic ring, alcohol. And notice, like others we've talked about, it's an aromatic compound. I'll never ask that on tests, but it's good to know that things you're learning about are in our everyday life in various places. All right, hold on. I've got too many things open. And I'm going to have to close this. And this. Sorry about the technical difficulties, but sometimes when I have too many things open, I've got a lot going on my computer to give this class going on. Sometimes things hang up. All right. Now you can see the structures, which, now, how do you make an aldehyde or ketone? And let's look at the following. Some of this you already know. Now, to make an aldehyde, you can oxidize a primary alcohol, which we talked about. So let's just do a couple examples quick, because we've already done this. But if you take a primary alcohol and oxidize it, and now you know you lose a hydrogen here, hydrogen there, form a carbon-oxygen double bond, you make an aldehyde. And therefore, if I take this, what do I have? Primary alcohol. And I'm oxidizing it. Oops. Lose this and this, and I'll make an aldehyde. And what's our ethyl? The carbon with the hydroxyl group becomes my carbonyl carbon, carbon double bond to oxygen. In this case, you break carbon-carbon single bonds, 3 across, and you get this aldehyde. Your turn. And why don't you give the product or products for the following reaction? Have fun. And remember, we're going through the nomenclature, then how do you make it? And then how do you react aldehydes and ketones? That's the fun part, how to make them and how to react them. All right, I think everybody's done. Let's do this. And if we look at this molecule, we say what's different, what's not carbon, what's not hydrogen. Ooh, oxygen with a hydrogen on a carbon, that's a primary alcohol. Why not just alcohol? Because when I see oxidation, O in a bracket, I know it's good to consider primary alcohol or secondary. And this gets oxidized and you lose the hydrogen there and there, and you make an aldehyde. What's my R group here? These carbons. And a carbon with the hydroxyl group is a carbon double bond to oxygen, the aldehyde, the carbonyl carbon. So I have 2 4 cross. Remember, you don't break carbon, carbon, single bonds. I have a methyl group here. Which carbon had the hydroxyl group? This one. And I know there are 4 bonds to carbon. So I can put it in my hydrogens. And that's how you do it. Oh, let's do another one. I'll throw you a curve. What would be the organic product or product for the following? Yeah, it looks like everybody's done, so I better get to work. And what do we have here? An alcohol, and it's a primary alcohol. And you're oxidizing it. And what do you get? An aldehyde. And what's my R group? Methyl. The carbon with the hydroxyl group becomes the carbon here. And there are 2 ways you could draw that. One would be this way, or the other would be perfectly correct, which I usually don't, which is why I wrote it differently that way. They're the same thing. Now, one thing I should mention, when I worked at Borden Chemical, the company that made formaldehyde, which is now Hexion, they would take methanol, this alcohol, and air oxidize it using the oxygen air. They'd use a catalyst, which I can't tell you, it's proprietary secret, and I've signed, which is still in effect, non-disclosure agreement. But I can tell you this because this is widely known. And they'd make formaldehyde. And we made about 100 and 125 million pounds when I was there years ago per year, lots of it. And that's how you make an aldehyde. Now, if you take a secondary alcohol, and you already learned this, so we'll go through it quickly, and oxidize it, you'll get a ketone. And sometimes I'll write like this. And if you oxidize it, what is this? Alcohol. It's a secondary alcohol. secondary alcohol, oxidize it. I keep on when I'm doing a hydroxyl group. I got hydroxyl group on the mind. And you lose this hydrogen, this one, and you form a carbon-oxygen double bond, carbonyl, and it's a ketone. So here, if you take and react that, what do you get? I'll call this R. I'll call this R prime. They're still attached to the carbon with the hydroxyl group, which becomes this carbon. And you get that ketone. And why don't you try this one on your own and have some fun? What would be the product or products for the following reaction? Oh, it warms my heart to see everybody working on organic chemistry. Thank you. And when you're done, give me a thumbs up. I think everybody's done. Let's do it. What do we have here that's different? What's not carbon? What's not hydrogen? Ooh, hydroxyl group on a carbon. It's an alcohol, but this is a secondary alcohol. And when you oxidize it, you lose this hydrogen, and form a ketone. You break carbon-carbon single bonds? No. So I have 1, 2, 3, 4 across plus my methyl. I'll still have 4 across plus my methyl. Which carbon has the hydroxyl group? Will be the carbon that's double bond to oxygen. And there are 4 bonds to carbon. And I put in my hydrogen. Oh, let's do one more. Dr. White's enjoying this. And there's your one more. And I think everybody's done, so I better get to work. And what do we have here? A secondary alcohol. Look for what's different, what's not carbon or hydrant, the oxygen with a hydrogen hydroxyl group. And when I oxidize it, I will get a ketone. Well, in this case, what's R and R prime? Methyls. And the carbon with the hydroxyl group will be the carbon double bond to oxygen to carbonyl carbon. Does anybody see the significance of this reaction? Take a look. What do you think the significance of this reaction is? All right, I think I better, you all give up? Let's find out. Well, what's this molecule? This is 2-propanol, also known as isopropyl alcohol, which is found 70% or higher, depending what kind you get, in rubbing alcohol. And what's this molecule? It's acetone. So if you're ever on a desert island and you can't get your nail polish off and you've got rubbing alcohol, you can oxidize it to make acetone and now get your nail polish off. That's the significance. Now you know how organic chemists, synthetic organic chemists think. I always like to play mind games with myself or puzzles. How would I do this if I were trapped somewhere and I had to make it? I couldn't just go out and buy it, which is an interesting mental exercise. Now, one thing I should mention that I learned a couple of years ago is, if you notice, Dr. White doesn't wear nail polish, even though back when my grandfather, men used to have at the barbershop, put a clear coat on their nails. So they did. But anyways, how many of you are familiar with the nail polish? You have to put your fingers underneath a UV light to make it cure. And that stuff makes a really hard, I've been told, very durable nail polish. By the way, nail polish is very, very sophisticated organic chemistry. Well, it turns out it's so durable that the most common used to be nail polish made by ethyl acetate. Why? Because it smelled nicer and didn't burn your fingers if you had any cuts or scrapes on there. Did a poor job of taking that off. And what made a comeback? Nail polish remover with acetone. Every once in a while, when I remember, and I'm in a big box store like Target or Walmart, I'll go where they have the nail polish remover to see which one has more shelf space. And for many years, there was very little acetone. Most of it, I'll teach you, ethyl acetate. Now it's quite equal or even more acetone because of that special nail polish. All right, let's talk about a very special reaction. Why is this special? Because this is one of those special reactions that you can make a carbon-carbon single bond. If I take a benzene ring, and this is called an acid chloride. If I had a 2-semester class, I'd be teaching about these. But it's a very reactive chemical. And then I have a catalyst, aluminum chloride, trichloride, which you've seen before. And this is called Friedel-Crafts acylation. Just like a carbonyl group, and this I really won't go into that much. When you have a carbonyl with an R group bonded to something else, this is called an acyl group. And what happens is this acyl group you put on the benzene ring, remember electrophilic aromatic substitution, and now you make what's called an aromatic ketone. And that's Friedel-Crafts acylation. You've already learned alkylation. and you make that special thing, a carbon-carbon single bond. Very rare, very special, very important. And if we look at this, what's different? Ooh, a benzene ring. Here, ooh, carbonyl, and it also has a chlorine on it and carbons. And this is an acid chloride. And what do we have here? A catalyst, aluminum trichloride. And this is Friedel-Crafts acylation, and I put on my acyl group. In this case, what's our methyl? And I make this carbonyl bond to carbon-carbon single bond to the benzene ring. My R group is still there, and I make this aromatic ketone. And that's Friedel-Crafts acylation. And if we look here, here's one for you to try. What would be the organic product or products of that? Now we're getting some really sophisticated organic chemistry and exciting molecules we can make. Like I said, I'm having a good time. I hope you are too. All right, anybody need more time? Let's do it. All right, what do we have that's different? Ooh, a benzene ring. That's different. What do we have here? Carbonyl chlorine. That's an acid chloride. What are we reacting it with? Aluminum trichloride. And this is Friedel-Crafts acylation. You put an acyl group, carbonyl, with an R group on the benzene, and you make an aromatic ketone. And what's my R group? These 4 carbons. So I have my benzene ring. It doesn't matter which carbon you put it on. I'll put it here. And my R group. And there you go. Oh, we got to do another one of these. And there you go. What would be the organic product or product for the following reaction? All right, anybody need more time? That's the one bad thing about, well, sort of bad about on Zoom. In the classroom, I can look at the students and tell when they're done. Well, it looks like everybody's done, so let's do it. What do I have here that's different? Oh, I got a benzene ring. But here I got a benzene ring, but it's not going to react with this. But it's on a carbonyl, carbon double bonded oxygen with a chlorine. That's an acid chloride. And my R group is the benzene ring. I have aluminum trichloride. And I make that something very special, very rare, carbon-carbon single bond, and make an aromatic ketone. So if my R is this benzene ring, what do I make? This aromatic ketone, and this is called benzophenone. Now, one of the things I've been saying, and I already said today, is you should ask the question, why am I learning this? And the obvious answer is you want to get a good grade so you can get into a program or a school that requires organic chemistry. Well, why learn about this? Why learn about Friedel-Crafts acylation? Why? Well, it turns out aromatic ketones have a very special property. They can absorb UV light and the energy from that. Now, where would that be important? Well, if I don't want to get a sunburn and cancer, skin cancer, and aromatic ketones like benzophenone are used in sunscreen and suntan lotion to protect your skin from the harmful effects of the sun and ultraviolet radiation. Now, it turns out that when they absorb this energy, they can release it certain ways, especially if you're doing chemical reactions. There's a whole series of chemical reactions that I could do a whole 2-semester graduate level course that unfortunately we're not going to cover, called radicals. And aromatic ketones are used in called initiators. They start what's called photochemical reactions. And photochemical reactions are a whole branch of chemistry, organic chemistry, unfortunately, we're not going to get into, that you shine a light on something and it causes a chemical reaction. Now, one place that's been used is your nail polish. And I'm sure they have an aromatic ketone. Now, another place where you want to have that type of, it's called photochemistry, is when you're doing very high speed printing, like in newspapers. And there they use aromatic ketones, which you make by Friedel-Crafts acylation to do photochemistry, so they can put the ink on super fast and it cures like that because they shine a light on it. And the aromatic ketone helps make that happen. So that's why you're learning this stuff. So next time you see someone putting their fingers under light to cure, harden the nail polish, or if you see a newspaper, which I haven't seen in a long time, or even high-speed printing of books, which I do see every once in a while, that's due to aromatic ketones in part. Let's do a synthesis problem. And the question is, what two things would you react with aluminum trichloride to make this compound? Your turn. For those who didn't notice, because of some personal things that I got involved, I had to take care of. I fell a little behind in my video posting, but we're now up to date as of yesterday with all lectures, and I'll try and keep on track this week and coming weeks. And when you're done, give me a thumbs up. All right, I think everybody is done. Let's take a look. And if we look at here, what are we trying to make? What's different? Ooh, I got a carbonyl. I've got carbons here, carbons here. This is a ketone, but this is a special ketone. One of the R groups of the ketone is a benzene ring, and it's an aromatic ketone. Also, this gives it away too. And how do I make that? I react what two things together with the presence of aluminum trichloride, and that is a benzene ring plus an acid chloride. And what's our ethyl? So one of these, it doesn't matter which one you put first, is a benzene ring. Then my acid chloride, 2 carbons, carbonyl, and the chlorine would be this. And that's how you do the fun part. How do you make something like this? Well, this is how you figure that out. And that's how you make aldehydes and ketones. Now, I should point out, and when I was making certain aldehydes or ketones in graduate school, I would do the oxidations. I never used aromatic ketones, so I never did Friedel-Crafts acylation, but I did work with acid chlorides, but other reactions. All right. Now, it's time to look at the carbonyl group again, because some important things. Next couple slides, click. I'm going to turn the switch. Will this be on a test to the off position? But by learning this material, even though I won't put it on a test, it'll help you understand when we do some reactions, which I will put on a test, or you really should know. Now, when we talk about the carbonyl group, and remember I did part 1 earlier, carbonyl group, carbon, double bond to oxygen, and an aldehyde or ketone, when R prime is hydrogen, aldehyde, when R prime is carbons, ketones. Now, the oxygen is more electronegative than carbon. That means when they're sharing electrons in the double bond here, oxygen says, I'm stronger than you are. Let's keep the electrons, share them, but a little closer to me than you. And they do. And what happens is there's a slight charge on each of the atoms. We call that polarized. And this is slightly positive. The oxygen is slightly negative. In chemistry, delta, the Greek letter in uppercase, means difference. Like delta T is difference in temperature. Now, this is lowercase delta, and that means little difference. If I could spell. Did I tell you I was always the first one down in spelling bee? Not my cup of tea. Chemistry and math and science, nope, I won, but not spelling. So the carbonyl carbon is polarized, and that means nucleophilic attack occurs at the carbonyl carbon of the carbonyl group. What does that mean? Well, let's parse the word down. Nucleophile. Well, how many of you ever heard of an audiophile, which I am? Audio, music, file lover. Now, nucleus, what's the charge on the nucleus of an atom? It's positive. So a nucleophile is a certain reagent or species that's looking for positive charges. And we're going to find a positive charge at the carbonyl carbon. And that's what happens. And next slide, let's see, nucleophilic addition to carbonyl groups, nucleophiles attack. Did I tell you organic chemists are very violent? We use terms like attack. And actually, that's how we do describe this. Attack the carbonyl carbon of the carbonyl group. And the pi bond is broken, a new sigma or single bond is formed. And here I have an example where I have a nucleophile with an actual charge, and this arrow shows it will attack this, and the electrons here go there. And remember, this is a pi bond and a sigma bond. Now, it's not the same as a carbon-carbon double bond, because both carbons are the same electronegativity. But here, remember, this is slightly positive and this is slightly negative, and this attracts nucleophiles. And you get something like this, where you formed a new bond and you've broken the pi bond. Another way of looking at it is, if you have a nucleophile of the form HNU, where this is a plus, this is a minus, the nucleophile attacks that, opens it up, and I don't have this, and you make this new type of molecule. And we'll be learning about that. There are a number of reactions that follow this. Oh my goodness. If I look at the clock, we're just about out of time. Now, listen carefully. After I say goodbye to you, I'm going to stick around for a couple minutes and show you something nice, show and tell. For all of you who are pet lovers, you should stick around. Don't forget, tonight, I have my office hour from 6 to 7:15. Always feel free to come by to ask questions. I'll be there, always, because I'm supposed to. It's in the contract. But even if it wasn't, I'd still be there to help you out. And don't forget also, hand in the lab on Wednesday. That's due this Wednesday, by Wednesday. And also, I'll go over the alcohol problem set. Let me go through that again. Wednesday, alcohol problem set. Don't forget to do the lab. I'll post sometime tomorrow the lab we're going to do on Wednesday. And with that, I'm going to say goodbye, do my normal goodbye, and then I'll show you something, show and tell about pets. And with that, thank you for coming to my class today. Gehen gesund. I'll see you on Wednesday.